You just can't escape me. I know. It is the third section of this pre-work we're doing to Module 8. So turn your notes to this page and let's get started. Hey, make sure you have a calculator handy too. All right, our essential question is this today. How do I use indirect measurement to solve problems? Sometimes it's just impossible to physically measure something directly, okay? For example, there's no way we would take a tape measure and measure from here to the sun, yet somehow they've managed to determine that that's 93 million miles, Earth to the sun. Okay. They've used proportions and indirect measurement to do this. So what are we talking about when it comes to indirect measurement? This means it is some kind of method or a procedure that we use, and we use it to find a missing measurement or a part. So I'll say measurement in or by using similar figures or similar shapes. A lot of times it's triangles, might be rectangles sometimes. And basically, it's all about proportions. So get your calculator ready. And I'll tell you, pause the video as you need it so everyone can catch up. And away we go. All right, let's head to the next page. Here we go. All right, so these first ones, they're just set up as a regular triangle. Okay, we're not dealing with realistic things just yet, but I want to make sure you feel comfortable in using numbers that don't always work out perfectly and making sure you're setting things up right. These two triangles are similar. Sometimes we use this symbol to illustrate that, okay? Find the length of side EG. They've marked it with X. So, first of all, I need you to write a proportion to show the work. All right, so you could set it up as in the baby triangle, say vertical side to the bottom, 3 to 4, has to be equal to the big triangle, vertical side to bottom, 10.5 to X. Or maybe you like to think of it this way. Corresponding sides, the vertical side in the baby one to the vertical side in the big one. 3 is to 10.5, as 4, the bottom side in the little one, is to the bottom side in the big one. Regardless of how you do it, go ahead and solve this one right now. You can pause the video, wait, see when you've got an answer, and let's see what you come up with. Either way, you should end up with using cross products that 3x equals 42. Divide both sides by 3, and you should get that x equals 14. Please make sure you label it with the appropriate unit, 14 feet. All right, let's look at the next one. On this one, it says these two triangles are similar. There we go. Set up a proportion to solve the length of missing side HI, which looks or appears to be on this slant here. So let's see how this one can be set up. I'm going to do it this way. Vertical to the slanty side. So 6 is to 7, as in the big triangle, 8, the vertical side, is to its slanty side. Or maybe you want to do corresponding parts. 6 is to 8, as 7 is to X. Either way, you are going to wind up with the same cross products. So I'll give us some more room here. So here, just simply say 6 times X has to equal 7 times 8, which is 56. You would get the same thing in this one. Divide both sides by 6, and you end up with, all right, now 56 over 6 would be 28 thirds, which is the same as what, 9 1/3, or as a decimal, 9.3 repeating. Use exact. I didn't say anything about rounding these guys, so go ahead and use the exact answer, but please label it inches. 9 1/3 inches. There you go. All right, let's move on to the next ones. Now we're actually getting into some shapes here. All right, first one. Here's a building. Here's its shadow. Nearby, here's a tree and its shadow. I just don't know how tall the tree is. So pick a variable to represent it. If you want to use X, go ahead, or T for tree, and set up a proportion. 30, like building height to shadow, 30 to 75, equals tree height, the unknown, to its shadow. Or you could say 30 is to T. You could come over and like write it this way if you like. 30 is to T as shadow is to shadow. 75 is to 35. Regardless, you're going to get the same cross products. Take 30 times 35. I think that's 1,050. 75 times T. Go ahead and divide both sides and get your final answer. Make sure that you are labeling your answers in all of these. And I believe once we divide, we get something like 14 feet. Now, ask yourself, does that make sense? Let's see. It definitely is shorter than the building at 30 feet. And when I look at this relationship, the shadow is much longer, more than twice the size of the height. And here, if this is 14 and 35, it's 35 is more than twice that. That's a reasonable one. Now, this one, put a big old star by this one. And here's why. You've got two triangles here. As you see, this is the pond. And we have this side of the triangle that we're trying to figure out the distance. So you can call this D or X or whatever you want. But this is what we're looking for. Tamara wants to know the width of the pond at the park. I guess you could use W if you want. She drew the diagram and labeled it with the measurements she made. How wide is the pond? Okay, now here's the thing. These two triangles are not in the same orientation. I cannot do this unless I redraw this bottom tiny baby triangle so that it's in the same orientation. In other words, I'm going to turn it and redraw it right next door here like this. So here's the top, which is 15 yards. And then whoop, it goes like this, kind of, sort of. There's my right angle. This is the 9-yard side, which corresponds to the 36. Okay. This one, maybe you can see what's going on here to get an answer, but I always want you to draw the proportion or write it out anyway. So you could say, all right, this distance is to 36. So the width of the pond is to this side as 15 is to 9. Okay. Or you could say D is to 15 as 36 is to 9. That works as well. But you will end up with this. D times 9, or 9 times D, equals 36 times 15. And once you get that value, or you can just divide by 9 right now, you will get D equals, you can crank that out, or in the olden days, we would simplify before we multiplied. You should get 60 yards. If you ever see one of these where you've got this crossing of 2, make sure that you get the right orientation on those triangles to match up the corresponding sides. Now, granted, this time I only gave you 2 measures or 2 sides to deal with, but if they gave you all 3 sides in the bottom one and 2 of the 3 sides in this one, you got to be careful and make sure you match them up. Okay. All right, I think we've got a couple more. At the bottom of this page, let's see what's going on here. You've got 3 things going on, and it's really hard to tell, but this is like a small kind of shrub there. Here's the house, and then here's this tree. And everything has some kind of shadow here. Let's talk about the shrub. The shrub is 4.5 feet tall, and its shadow is 9 feet. So I'm kind of going height to the shadow here. They asked, how tall is the house? I don't know how tall the house is. So pick a letter there for the height of the house. Maybe you want to use H. The shadow here is the shadow of the house, which is 72 feet. So you can set up this proportion and go ahead and solve. Okay, 4.5 is to 9 as H is to 72. You can cross multiply. 9 times H equals 4.5 times 72. Crank it out. Let's see here. I think that gives me 324. And then simplify by dividing both sides by 9. And you should get the height of the house is 36 feet. Circle it. Cross that one out, okay? Cool. All right, 2 more. Let's go to this next one. Here's one that's crisscrossed or flipped around. I want you to try and solve the next 2. Pause the video till you think you've worked through these 2, and then when you turn it back on, see what you've got for a solution. W is to 7 as, now I'm going to flip this guy around so that baby triangle down here with that same right angle is the 5 is on the bottom and the 5.7 is the height. So if I go height to bottom, I'm going to go height to bottom. And then go ahead, cross multiply and solve. I get this 5W equals, let me get my notes here, 39 9/10. Then you have to divide by 5. And you should get 7 98/100, and it's meters. Boom. That's how far it is across the river. The last one, now be careful. A yardstick has a 2-foot shadow. So here's your yardstick here, and the shadow is 2 feet. We can kind of visualize a triangle there. At the same time, you have a tree. That's my hideous artwork for a tree. This tree casts a 6-foot shadow down here. So this is 6. I don't know how tall the tree is. Over here, I have the yardstick and a 2-foot shadow. How many feet are in a yard? Do you know that? It's 3. So here's your similar triangles here. 3 is to 2 as T is to 6. When you solve that one, you should get 9 feet. All right, your assignment's in the packet. Check the front border, check Schoology, and as always, may the force be with you.